Hello, today I'm gonna serve the 135 candy. This is the first video about this problem. I'm gonna explain another solution, which is the fastest way, and implement the real one-pass algorithm. I'm gonna skip the explanation on this problem. You can refer to my first video. Okay, let's jump onto the real one-pass algorithm. This is the official solution provided in Liquid.com. You can see the detailed explanation in the website. Okay, let's get started. At first, the vertical axis shows the rate, and the horizontal axis shows the allocated candy count. So let's see how can we allocate the candy count during one pass iteration. Okay, we can start to iterate from the left side toward the right direction. So during the iteration, we can see that the rate value is increased, and also the candy count is increased. And we reaches the peak point, which is the PT5. And then we go down to the PT8, and then go up again. At this point, we can calculate candy count during the slope. The length of slope A and B can be measured during the iteration by increasing up and down variable. So up is 4, down is 3. Using these counts, we can calculate the candy count in constant time. We can call the function count_n, which is calculated n multiply n plus 1 divided 2. So count 4 is 10 and count 3 is 6. So we calculated the candy counts in the left slope and also in the right slope, except the peak point. We can include the candy count of the peak point, the max value of up and down, and plus 1. We can do the same calculation for the second slope. But there is a tricky part. Candy of peak 8 is added twice. So we have to add -1. So the plus 1 in the peak point is removed. The second slope is actually calculated here, and then the third slope is calculated here. The third slope is only composed of downslope. The slope length will be 2, and the next slope will be calculated here, and the last slope will be calculated at last moment. Okay, I already told you the first calculation of the slope candies, and as I already explained, there is a duplication point. PT8 is calculated twice through the calculation of adjacent slope. So we did -1 and the previous peak point. It happens the chaining way. But as you can see at the end of the iteration, there is no duplicated candy. So the last -1 is not complemented. So at last calculation of slope, we should add +1. That's the tricky part that we have to understand the solution code. Okay, let's see the implementation. Okay, let's see candy function. There is a single for loop to iterate the ratings array. This code is the slope decision. If the slope is climbing, which means ascending order, new slope would be 1. But if the slope is in descending order, the new slope will have -1. This is the condition to know the calculation point. If old slope is ascending and the new slope is 0, we should calculate the candy count. You can see in the diagram the first calculation point belonging to this condition. And if old slope is descending order and the new slope is more or equal to 0, we have to calculate the candy count. This condition is for the case of 1 to 3 in the diagram. So at this point, we have to calculate the candy count using count function in constant time. And as I already explained, the max up and down is less than the peak point candy count by 1. This is for subtracting the duplicated candy count occurring at down peak point. And we are calculating the slope length here. If the slope is over 0, we have to increase the up count by 1. If the slope is under 0, we have to increase the down by 1. If the slope is 0, it means that we can allocate just one candy because the neighbor's rating is the same. And at the end of for loop, all the slope is updated with new slope. And lastly, we have to calculate the candy count of remaining slope. At this point, we have to add the +1 to complement the -1 in the previous slope calculation, and lastly return candies. Okay, this is the fastest solution among the previous solutions that I explained in my previous videos. Okay, thank you for watching. See you next time. Bye bye.